So we have the block one, classified questions, page number 14. State one advantage and one disadvantage of using wind turbines. So renewable, that's right, renewable energy resources or low running cost is there. And it's not reliable because the wind speed changes throughout the day. It's take a lot of space. That's good. Noisy. That's also correct. Figure 2.1 shows a wind turbine with a wind speed is 16 meter per second and air swept out by the turbine blades. The wind blow at a speed of 16 meter per second towards the turbine blade in 1 second. A volume of 24,000 meter cube of air passes through a circular area swept out by the blades. The density of air is 1.3 kilogram per meter cube. The mass of the air that passes through a circular area that's swept out in 1 second. So we have the density and we have the volume. We need the mass. So what's the formula we use? So density is mass over volume. So if we need the mass, so mass will be density times volume. So density is 1.3 because it is already in kilogram per meter cube. So and volume is already in meter cube. So we multiply. We got 31,200 kilogram. When the value is too large or too small, the best thing you write in scientific form, like 31, you can write 31.2 into 10 to the power 3 kg. This is not wrong, but you can also represent in exponents. So 31,200 kg, the kinetic energy. So how to work out the kinetic energy? That is half mv square. So it will be half the mass. We already calculated 31,200 and the speed is 16. But this is a common mistake which students do is they forget to square. Like they write the formula, but when they write show a substitution, they forget to square. So remember that you have to square the speed. So it will be 4 exponent 6 joules, or we can say 4 megajoules of kinetic energy, which is a very high proportion. The next is related to the force. An object is moving in a straight line at a constant speed. State 3 ways which the force can change the motion. There's an object which is moving in a straight line. This is the direction of the motion, say towards right hand side. If the force act, so when the force act, it can change the direction. Like if the force acts perpendicular to the motion, it will change the direction. Or if the object is moving and the force is acting on the object, so force can slow down, change the speed, you can also say. If the force is acting same as the direction of motion, it will accelerate. And if it is acting opposite to direction. But these two, like slow down or acceleration, will be refers to the same effect. Like force can change the shape, force can change the size. So shape and size are referred to the same point. Same thing, force can change the speed, like it can increase or decrease the speed. So that is, both are referred to same point. So what else we can write? We can mention it can change the like motion. So what are the effect of the force? You can say the force can change the motion, force can change the direction, force can change the shape. So direction of a moving object, change the motion of an object. Motion here refers to, like if it's a moving object, it can stop. If it's a stationary object, it can move. And you can refer to that speed as well, which is also coming in the motion. Yeah, so because in the question they ask 3 ways it changes the motion. So that's why you can write changes the speed. I'm talking about the effect of the force. I'm not referring to the question. I'm referring, if the question is what are the effect of the force, you can mention it can change the direction. It can change the force can change the direction. Force can change the shape. Force can change the size. But here to motion, you can write here, it can cause acceleration, deceleration, or it can change the direction. That's fine. with reference to the question, you can write those points. But if they don't ask, they just ask state the effect of the force, then you can write others as well. Figure 3 point, next question. Figure 3.1 shows an object suspended from two ropes. The weight of an object is 360 newtons. The magnitude of the tension in each rope is T. In a space, determine the tension T by drawing a vector diagram. So vector diagram, what we have to do, we have to scale, because vector diagram cannot be done without scale. But according to the change in the syllabus, the same question now can be done by both ways, Pythagoras or a vector diagram. Because this is from the old past paper, so only option was available that use a vector diagram. But how to do a vector diagram? In the question, we have the resultant is given, because look, this tension T is there, which is making angle 45. Another tension T is there, making angle 45, and the weight is acting downward. Now, the result of these two tensions is actually equals to weight. When these two tensions will combine with each other, because like if we draw a vector diagram, we draw first tension T, then we draw the second tension, that's also T. So we draw the first tension T, we draw the second tension also T, and we'll join from tail of the first to the head of the last. That will be the resultant. And this resultant is actually equals to W. So the resultant of the two tensions, the vector sum of the two tensions is equals to W. So we can, if the W is equals to 360 Newton, so means this is also 360 Newton. So how we can do this question? First, we select a scale. For a vector diagram, we have to select a scale. It should be like 360, because you don't have a scale in Newton. So if I select, say, 60 Newtons is equals to 1 centimeter. So 360 Newtons will be 6 centimeter. So we'll draw, because we are drawing the weight, which is 6 centimeter. So we draw 6 centimeter. So the idea is that the two tensions which are acting, making angle for like 45, the resultant of these two tensions will be equals to weight. So the weight, because the weight is 360, so it means resultant of these two tensions is also 360, which is 6 centimeter according to our scale. Now, the two tensions, which we can use a triangle method, or we can use a parallelogram method as well to solve this. If we use a parallelogram method, we draw both vectors from the same point. So we'll draw one of the vectors, and both vectors are T, means they should have the same length. So we'll draw at an angle of 45, we'll draw two lines. From the bottom, we'll draw a line with angle of 45. Length we don't know, because we don't know what is the magnitude. So at an angle of 45, because this angle with a vertical, if this is 45, this angle will also be 45. So we'll, at an angle of 45, we'll draw a line T. We don't, this can be any length, because we don't know what is the magnitude of T. And same thing from the top as well, because the second vector is also making 45. So we'll draw the second vector at an angle of 45 from the top, and any length. So what will happen? These two vectors, like two tensions, will intersect. The point where these two will intersect, and we'll erase the other part. So this one is T. This one is T. This one is also T. And this is actually W, or you can also say the resultant of the two. Now what we have, how to get the value of a T? You just have to measure this length. You have to measure this length. Example, this is just an example, say it is 5 centimeter. So if this is 5 centimeter, as we selected the scale in the beginning, that our 60 newtons is equals to 1 centimeter. So if 60 Newton is equals to 1 centimeter and we got 5 centimeters, so how many newtons will be there? We cross multiply. So in that case, we'll get 300 newtons. Because I did not measure, that's why it may not match with the marking scheme answer, but this is how it can be done. This is the scale diagram in which we use a triangle method. We were having a resultant, that's why we make the two vectors. Usually they don't give the resultant. Usual questions are they give you the vector and then you have to find the resultant. But in this one, we have the resultant and we have to find the initial vectors. If the same question you want to solve by using a Pythagoras theorem, so how it can be done? So this one is t, which is 45. Then you draw the second t at an angle of 45. And what about the resultant from tail of the first to the head of the last? That will be the resultant. So it should, whenever you're using a Pythagoras theorem, the condition, it should make a right angle triangle. If it's not making a right angle triangle, you cannot apply the Pythagoras theorem. So this tension is T, this tension is also T, and this resultant is 360. Now, what will be this angle? Because here it's 45 and here also 45. So how much is this angle? Whenever transversal intersect of the two parallel lines, like if I have two parallel lines and I cut them, so the angle congruent, the angle which are formed, the alternate angle which are formed are congruent. Means if this angle is 45, so this will also be 45. That's a rule for the geometry in maths, that whenever transversal intersect of the two parallel lines, the alternate angles which are formed are always congruent. So means if this is 45, this will also be 45. So means this total is 90. So with reference to this 90, what we have, so we can use a Pythagoras theorem. Like, for example, we call this as a base, we call this as a perpendicular, and we call this one as a hypotenuse. So we use Pythagoras theorem that hypotenuse square is equals to base square plus perpendicular square. So hypotenuse square is 360 square, base is t square, perpendicular is also t, because like both are t, so t square. So 360 square. So 360 square plus 2t, t square plus t square will be 2t square. So 360 square is 129600. And t square plus t square is 2t square. This 2 is multiplied. Other side it will be divided. It will give 64,800 is t square. If we want to take t, we take a root. What's the final answer? The square root of 64,800. Square root of 62,400 is 254. So you will mention 254.55 or 254. Three significant figure, Newton. So that's how, if the same question, because now you will have both options will be there in exam. Either you can use the scale diagram or you use a Pythagoras theorem, because now the vectors which will be given to you are only 90-degree or making a right angle triangle. Before it was not like this. Before they used to give different angles of the vector. So the total sum, like it won't, sometime it was forming a right angle, sometime it was not forming a right angle triangle. Is it clear, this one? Anyone having a doubt or a question till this point? Any question or a doubt? Okay. The next question is related to the motion. A rocket is launched vertically upward from the ground. The rocket travels with a uniform acceleration, means uniform means constant acceleration from the rest. So starting speed is 0 if something start from rest. and we need acceleration in 100. So acceleration, 1 mark is always writing a formula. So you should write a formula first. Acceleration is v minus u over t. The final speed is 120 initially start, and then so it will be 120 divided by 8, which is 15 meter per second square. On the figure, draw a graph for the motion of a rocket for first 8 seconds. So we want to, because we have the result, like in 8 seconds, the speed was 120. So when the time is 8, 10 boxes equals to 5, so each is 0.5. So this one is 9, this one is 8. So when the time is 8, the speed is 120. On y-axis, 10 boxes equals to 50, so each is representing 5. So this will be 110 and this will be 120. And because the acceleration is constant, so as the acceleration is constant, so it will be a straight line. Because speed time graph, the slope represent the acceleration of an object. Use the graph to determine the height of the rocket. So how we can use a graph to determine the height? Whenever a speed time graph, look, uh, whenever speed time graph is there, you will always use area under the graph. Some student use the formula that speed is distance over time, and the distance will be speed multiplied by time, and they use the speed 120 and the time 8, and that will be wrong. Why this will be wrong? Because in this case, the speed was not 120, it was changing from 0 to 120. So if the speed was, if you want to use a formula, then, and the speed is changing, then you're supposed to substitute the average speed. So what will the average speed? So average speed will be 0 plus 120 divided by 2, then into 8. This will give you the right result. Or the second thing, what you can do, whenever there's a distance time graph, a speed time graph, and you need a distance, the best thing is you find the area under the graph. So it is making a triangle. So what is the area of the triangle? It will be half base into height. So it will be base is 8 and the height is 120. So this will be 66 multiplied by 8, 48 and 480, and the unit will be meters. So either use area under the graph, or if you want to use a formula, speed is distance over time, check if the speed is changing, then don't substitute the final speed, substitute the average speed, the initial plus final divided by 2. For the time from 8 seconds to 20 seconds, the rocket rises with an increasing speed but decreasing acceleration. And then from 20 seconds to 25, the rocket has a constant speed but less than 120. We have to complete this. So for the first 8 seconds, the rocket was having a constant acceleration of 100, reaches a speed of 120. The next part they mentioned, from 8 seconds to 20 seconds, the rocket was, the acceleration of a rocket was decreasing, but the speed was increasing. So how we represent the acceleration, decreasing acceleration, the slope should decrease till 120. And then from 120, the rocket move with a constant speed. So this will be the last part of the graph, in which the speed of the rocket is constant. And they mentioned the final speed is below 100, below 200. So any value, it's not like, because the final speed is less than 200, so any value is acceptable. This question is related to momentum. The mass of an athlete is 71 kg, and this calculate the impulse. Impulse is having two formulas. Impulse is force into time, or impulse is the change in momentum, which is mv minus mu. So an athlete is there, as she crosses the finish line, she was moving at 10 meter per second, but she should slow down to 4. So if you want to calculate the impulse, it will be mv minus mu. Mass is 71. What about the final speed? The final speed is 4. And mass is 71 and the initial speed is 10. So 71 into 4 minus 71 into 10. What's the final answer? So impulse Newton second minus 400 into impulse can be negative because it's a vector quantity. So it can be negative or a positive impulse. Marking scheme answer, usually when they give the answer, they don't mention this negative sign because the negative sign has a significance in terms of a direction or the change. That does not have, like the magnitude, as we are calculating a magnitude. So like writing 426 is having the marks. Define the impulse in terms of the force in time. So what is impulse in terms of force in time? So it is a product of force in time. Then athlete takes 1.2 seconds to change his speed. So we already calculated the impulse, which was minus 426 Newton second. If we need the force, impulse is force multiplied by time. So it was 426. If you put negative, that's also fine. Because like the force is opposing the motion and the time is 1.2. So 1.2 is multiplied, other side will be divided. So negative 426 divided by 1.2. What is the force? For 426 divided. So 355 Newton is the force. A negative answer, which shows that it is opposing the motion or the object is decelerating. Another example, calculate the force required to give a mass of 70, acceleration of 6.4. So we have the mass of 71 and the acceleration is 6.4. We use a formula F equals ma. So mass is 71 and acceleration is 6.4. That will give us the force. 454.4. Okay. So whenever you write your answer, write in 3 significant figures. So if it is 454.4, just write 454. So these are some questions related to the general physics. Block 1.